Howdy, my name's Peter Jackson, and I am going to be giving this talk called Mulch, Microbes, and Minerals, Practical Solutions for Soil Alchemy. Standing here where a pond had been dug and a lot of tractoring happened, and so the soil, when I planted this tree, wasn't very good around it. It definitely was super compacted, super clay heavy, and it needed some help. So, of course, always one important mulch is grass mulch. And while it can break down and form mats that make it so water is less penetrable, I also have mixed in quite a lot of wood chips, which then decompose and help become really good fungal fuel. And so if we were to dig it out a little here, it would just be pretty much right now hard and impenetrable as a rock. We're at something like 9 inches of rain for the year, and then we go over here and I can just dig and dig and dig. And then I get into our friends, the soil aerators, the little rodents like moles and voles. In this case, hopefully moles. So yeah, I can get at least, a hand span down with the aeration provided by mulch, providing organic matter and helping to just keep water moisture in, and then that water attracts the mycelium. The mycelium attracts some worms to come eat it, and then next you have some moles digging tunnels to further help the soil aeration from the compaction. But a lot of this is just going to be focused on how do we transform specifically more like clay heavy soils, and by bringing in all the things that we can at a super low cost to just make it so we barely have to water. So, and in this case, this is a ginkgo biloba tree, and it's never been watered, but it has been, it was planted wrong in the beginning. But next we'll kind of walk around and look at some younger trees and how they've been more properly planted. Mulch, I mean, if you look around, like every fall, all the deciduous trees help with the mulch, and we're just trying to speed up what would be otherwise kind of slow processes. Like I'm going to walk over here just to show ramial wood chips. Ramial wood chips from arborists is one of my favorite things. Wasn't a resource I was connected into at first, so I primarily started with grass mulch and mulching things like stinging nettle and comfrey that were broader leafed. And but this is some ramial wood chips, so it means it's all from branches about 3 inches or less. That means there's a higher proportion of bark, which then contains more sap and trace minerals, as well as sugars, things that allow it to actually break down faster, because if this were just large branches in this climate, it's going to take years to fully decompose. And so this may not be available to us as a resource in the future, but right now I can go through truckloads of mulch every year, and that helps assist me as I'm in a rain shadow climate that also needs lots of help from just the last 100 years of logging and civilization in terms of how degraded the soil is. And so Walter Yenna says that you need 3% organic matter for there to actually be all the enough carbon springs between the soil mineral to really help create that loamy consistency we're going for, that actually is indicative that microbes are eating, digesting, pooping, and continually fostering a really beneficial soil microbiome. And so we're going to just walk over, look at, here's some a tree planted just this year. camera. get a lot of microbial action from the increased moisture content that the mulch helps sustain in the soil. And of course, buttercup is something that never really seems to go away, but you can see, this nice sort of already humus forming underneath the layers. This happens to be a wetter part of the property, so there's places where we probably wouldn't see the decay happening so fast. But a lot of little white fuzziness that I believe is indicative of what's called actinomyces. Then here's also a little bit of seaweed that's just been gobbled up by the little microbes. Because seaweed is the thing that is the crossover between both a mulch, a microbe stimulator, as well as mineral supplier, because having the seawater still on it, it contains every mineral that's ever washed down to the sea. So I do like to, in my strategy for low-cost ways to build soil health, I rely a lot on seaweed from local beaches, wood chips from arborists, the grass. Alright, we were a little interrupted, so I'm going to continue with my helper, who loves to help dig in the soil like a little mole himself. And so, as I was saying, my favorite methods of just supplementing both carbon and the microbes and minerals for the soil include things just like seaweed as a mulch, as both a supplier of minerals as well as a food for complex sugars for things like fungi. Then we have readily available grass mulch that I time the cutting of the grass with paying attention to when the seeds are about to form, so that way I'm not trying, even though I'm never going to necessarily get rid of certain things, I keep them at bay a lot more if I'm not spreading seeds into the mulch. So cutting it more at the hay than the straw level, the grass mulch 2-3 times a year is an invaluable thing. That's where I actually, before I had the arborist wood chip connections, I was definitely utilizing all the grass mulch and all the comfrey mulch and all the nettle mulch I could get my hands on. So then fire ash. Fire ash is a very valuable mineral component, especially in these calcium heavy soils. It wouldn't be necessary in a sandier soil, but in these calcium heavy soils it really helps because it's fire ash consists of 25% calcium, and then as I primarily focus on propagating fruit trees, then for instance, like an apple is taking lots of potassium out of the soil, and so then that's another big component of fire ash is the calcium. And then there is lots of trace minerals. So the recommendation for fire ash I've learned, this University of Pennsylvania study or something, was 10 pounds over 100 square feet can be applied yearly and won't be affecting the pH or anything. Also, of course, working with charcoal and biochar, that is another way to add the stable carbon, because if I were digging holes and stuff, all this carbon that's been broken down by the microbes from like organic matter material sources, the wood chips, the grass, that all can off-gas. That's also another thing about where while I'm putting carbon in the soil, there's always going to be something, but that's where as time's gone on, I don't really do much compost, never really was into turning compost. I understand better now how to make a static compost pile, but yeah, so many times from tillage and whatnot, we are losing organic matter anytime we're exposing these lower down soil depths to the air. It all just bleeds out into the atmosphere. We're really lucky to have enough rain that we are getting supplied with nitrogen, we're getting supplied with sulfur. There is probably, even just from being coastally, that rain would have just more mineral in it than some other parts of the world, but that is dubious, of course, because they say the Sahara gets fertilized with phosphorus from the winds of or the Amazon is fertilized by the Sahara by winds going all the way over the Atlantic Ocean. But anyway, so my young trees I really like to help establish much better now, because there's been numerous times when I was younger where we just kind of plant a tree and never irrigate it and walk off, and now I understand that I do sometimes, like this is a wetter spot, so this tree basically hasn't been watered. It's a whole year since being planted, and it was really historically wet spring, but then it's turned into a historically dry summer. And this area happens to get lots of dew year round. The grass is still the greenest in this area, and there's a creek drainage area and a pond, so there's just naturally, you know, where it's a microclimate that fosters some moisture to begin with anyway. But by helping really establish young trees with like a hardy mulch layer, sometimes I'll, even if I'm really trying to beat back the grass and buttercup, I'll be doing things like, you know, take some paper bags or some cardboard. And in fact, I did do that here, and we'll check how much that's broken down. Yeah, so cardboard is totally broken down. Of course, people say that the cardboard could probably have some industrial chemicals and whatnot, but there's some nice mycelium growing on it, so hopefully, you know, whatever bioremediation will be happening, because it's inescapable, all the toxins in the rain and everything at this point. You know, nowhere on planet Earth is safe. But yeah, so that's, of course, you know, where if you really want to get in, it's almost like lasagna layer garden creation, where if you start with some cardboard under the mulch or whatnot, then you can really start to create a better wiping out of the things that might be trying to compete for the young tree as it's trying to establish its root system. And while, of course, you know, you can get really into the companion planting and stuff, naturally what happens a lot is we get dandelion really helps out compete against the buttercup and the red dock, and we get lots of trailing blackberry growing everywhere. So yeah, there's introduction to like helping establish a good one-year tree, and then we'll walk further down. And we'll take a look at. Okay, so now here we are standing in front of a semi-dwarf winter banana tree. I do prune it pretty much every year, but I haven't watered this tree for basically ever. It was a very small tree for the first 10 years of its life. It was first planted on a hotter, drier hillside and then transplanted down here, but then because it was never getting any mulch, never getting any water in the summer, it just primarily stayed at a small size, and some other trees planted at the same time, cherry and an apricot, just died off. But these are trees planted almost about 20 years ago originally, or purchased like 20 years ago originally, and then around 2013, so now 9 years, this tree has been given mulch. And as time went on, started getting things like seaweed and fire ash, biochar, bokashi, different microbe teas. One I like to make is sometimes called jadam microbial solution or starch bubble tea, and that's basically going into the forests that are at least 100 years old and selecting some microbes from trees that are well established and also seasonally have to deal with drought and whatnot. And so by selecting from some things kind of similar, like an old growth maple, and getting a little handful of that leaf litter and forest humus, and then brewing up a tea using a simple carbohydrate source and not even aerating it, but just doing about a 2 to 3 day brew, you can make basically forest soil beer. And then from there, that also, you know, the older a tree is, the more time it's spent pumping root exudates into the ground, the greater diversity of microbial allies it's actually assembled. And so, let me grab this guy again. So, just like us, so, you know, like when you're first on breast milk, you're going to have a more simple microbiome, and as you get older, you're going to have eaten, and especially if you continue to eat a diversity of foods, you're going to have a richer microbiome. And so, what I'm trying to do then is, because this is you know, more a pasture, that you can jumpstart the microbial ecosystem by getting the donation from the old growth. And so that, in that case, you know, there's tons of microbes that are adapted to eating all the sort of cellulose starches and fungal fungal breakdown byproducts, and so you get the things that are being creating that aggregate like stability, where the forest is creating its own humus and continues to build on that humus layer, so that as you walk through some of these areas, it's literally some of the softest ground you can walk on. And so I'm going to just again like grab a handful of soil over here and show what happens. So this is probably had a wheelbarrow or two of wood chips applied in a donut ring around it, at least probably 3 or 4 times in the last 5 years. And then every year I will use the grass mulch. And the one thing that really finally beat Buttercup back like more than anything in the orchard was grazing sheep after all the fruit had been collected, so they weren't going to damage the tree. Yeah. So I was mentioning right before some noise was being made about if you are using mulch as a suppressant of weeds, sometimes there's just it's going to be a never-ending battle, and that's where you can bring in things like ruminant grazers. And actually that was the single best thing I've found for actually removing buttercup around the base of these trees. Years of mulching, the buttercup still will just be growing straight through it, but buttercup always does seem to harbor interesting microbes. I've heard a rumor it's maybe nitrogen fixing. I don't know if that's verified, but one thing I want to bring up though is because we did have a really wet spring, there was a lot, especially in the shadier parts, we get an apple scab, and that was just the amount of rain we were getting in up until late June. But then also it's a varietal thing. This is a more apple tree that forms clusters, and then over here we have a Spartan that instead of being a producer every single year, it is more of a every other year tree, and so its fruiting spurs are a little sparser. And this definitely they didn't seem to have, but it could be also a varietal thing, because no matter what, you can't grow every variety of apple perfect in every climate, and where it's about respecting the bioregion and the terroir in terms of actually getting what is adapted to your climate, or continuing breeding things that are epigenetically adapted to your climate. Because when we are creating all these food sources for microbes and creating healthy soils and producing a healthy nutrient dense food, what is going on is that we're basically like increasing the ability of the tree to fight off pests. It's being able to sustain itself with less input, so it can just go and do its thing. And then also, and that's the benefit of increasing the calcium content in your soil, is that you're also then helping create thicker cell walls in the fruit itself. The fruit is sweeter because calcium is known as a sweetener. And so we got little dinosaurs who eat the nutrient dense apples, and then they can just really rage on, But anyway, so yeah, here's where I first really had started mulching in a fruit bearing context, and it makes really delicious cider and just good apples to eat. And then one of my main microbe sources now at this point, after years of collecting wild microbes from the forest, has been, I take the spent yeast at the bottom of brewing, and that's full of all sorts of just wild yeast, and that's full of wild things like lactic acid bacteria. And so by going and spreading around the young trees, I'm helping establish a heirloom orchard environment, in terms of that there is the orchard becomes its own self-sustaining ecosystem. And so yeah, then okay, then we go from there. And what's the whole point of all this is that we're trying to have healthy trees, we're trying to have healthy soil, and then we're trying to have healthy human beings and not hurt the environment that we depend on. with chemicals, because as soon as you get into trying to chase one problem, you know, you start spraying Roundup for the weeds. Well, then you are depleting your minerals and causing them to run off faster. Then you're also causing less soil stability and less sugar to be pumped into the ground, and from the from the weeds being plants. Yeah, he's good. So the weeds are plants. The plants all photosynthesize. The more photosynthesis we can get happening cooperatively, the better. And so next, I guess, you know, if we kind of segue out of the mulch, we can start talking about the mineral aspect a little more. The knowledge has really grown exponentially in the last few decades about just what is an ideal soil, and soil has its components of sand and silt and clay, and in the middle of that we create this loam, and the loam is that compost, like humus rich, well structured, aggregated, doesn't fall apart when water hits it. It's not all going to be eroding away. And so in a lot of commercial orchards you have tons of herbicides being sprayed. In commercial vegetable and grain production, you have tons of tractoring, and that's all disrupting those fungal networks, disrupting that glomalin glues that are being able to hold together the soil and help start to build the aggregates. You're disrupting all these biofilms, and the soil even develops a crust itself to help both capture moisture and to get you know, just like the aggregate forming. And then of course you got like earthworms and stuff, their poop, that also is an aggregate structure, and then you got dung beetles rolling all the poop together into little balls. And so basically we're trying to have like a fluffy but well aerated and still full of proper mineral balance. And so while the mulch and stuff can help create that carbon matrix that really is able to hold the water and to keep the water from just leaching out, there is sometimes the cases where you have tons of minerals missing. And so some of those minerals, you know, it's beyond just nitrogen and potassium and phosphorus. You have next, the most widely used plant thing is calcium, and calcium is what do you call it, an electrolyte for the plants. In the plant electrical signaling and their pathways, they're using calcium to communicate in between their own self. And so then another important one would be like silica, and silica also is one that is responsible for like plant health and immunity. Then of course we got like even more trace elements. Then we, of course, magnesium. Magnesium is in the lifeblood of the cell, the chlorophyll, and the magnesium is going to be really high in a clay dominant soil, because the calcium magnesium ratios is one thing that people like William Albrecht help establish, where if calcium is the bigger molecule and then so is known to help fluff up or flocculate the soils, when you get to where you have a really clay soil, it means a lot of the calcium has been eroded and washed out. And so for instance, this is the really clay heavy soil. So in a clay heavy soil, we can benefit really from that calcium because the magnesium atoms are much smaller. So that's why when you get too much magnesium all stuck together, it forms the clay matrix. Now there still might be a lot of soluble and beneficial minerals in the clay, but it's not necessarily available if the plant and the related mushroom allies aren't able to stretch out and get their filaments and their root structures all able to bring that nutrition back to the plant. And so that's where if we get the soil fluffy with carbon and calcium, we can really start to get that nice loamy tilth that is also full of a proper mineral balance ratio in terms of being able to make it so the roots can penetrate, so there's water storage. Okay, that thing stopped there. Okay, so I've lost my my camera lady, She has taken a young budding horticulturalist to bed, and so next I am going to delve into that mineral balancing a little more. So people will say you want basically between 60 to 80% calcium as regards a maybe 10 to 16% magnesium ratios. You want to have the magnesium and the calcium balanced in such a way that, say you are in a sandy environment and you are in a place like New Mexico where you have an overabundance of calcium so much in your soil that it's fizzy. If you were to apply vinegar to it, that's where then you could do things like clays as a mineral component to help balance out your calcium magnesium ratio. Here we have less calcium, and so too much magnesium, or not too much, but the magnesium is not in a way that it's going to necessarily be the most available. And so this is where, using things, even seawater after the sodium and chloride next is highest in calcium and then magnesium, actually probably in that perfect ratio mineral balance, so, and followed by every other trace element that's ever eroded. And so trying to mimic the natural processes in such a way that we can understand like how does remineralization happen in natural ecosystems. We, as brought up earlier, rain can supposedly help precipitate basically everything. If the way the biodynamics practitioners put it, if you have the cosmic forces on the property aligned in such a way that they're able to receive, and help drag it down into the ground. But then the thing is, if your soil is really compacted and it's just going to continue to slough off the water instead of helping it infiltrate and penetrate and be captured and stored, then this is where, the soil mineral balancing, if like, it can vary based on location, but whether you're in a clay heavy area or a sand heavy area, you still generally have a large mineral deposit in the soil bank, so to speak. But then you have to know that sometimes you might be missing some things, and sometimes you can, of course, estimate this based on the appearance of the soil, like I said, with clay or sand. But then you would always probably benefit from doing soil testing if you're trying to amend super heavy imbalances more than just broad spectrum trace element remediation approaches using things like rock dust or seawater. So in terms of soil mineral balancing, my perspective is, of course, going to be based on the Northwest soil, which can vary even like region by region, even just on one property or in one neighborhood. However, there is also ways you can gauge it based on what sort of weeds you see. And then, of course, the things we often consider weeds that are long tap-rooted things are often very good at drawing up the minerals that are deeper underground, locked deeper in the clay layers, and helping bring it up and then help decompose it and make it more bioavailable in the actual rhizosphere layer at the very top where the most humus is, and how that actually helps understanding that, some things, of course, taprooted, they can go way down and they can survive the longer droughts. And then, of course, something like a very shallow rooted annual is going to have much tougher time, necessarily if it's trying to reproduce and go to seed. But then that's where, again, it comes back to variety and working not just with healthy soil, thinking that and mulch being able to fix your problems if the problem was something that you kind of created to begin with by choosing something that wasn't adapted necessarily well for your climate. And of course, climates are always changing, so this is where things move around. Birds spread things around, humans spread things around, they spread on their own. Okay, but this is where back to what's the remineralization strategies that the Mother Nature uses. So Mother Nature, for instance, in her use of forest fires, that is a way to both provide carbon that over time becomes what we call biochar. It also provides fire ash, which would be instantly beneficial, and in terms of the next rain would be able to make a lot of that soluble and go down into the root layers and start to help with their own nutrient acquisition as they are aided then by the fungi and the bacteria. So this is all unrehearsed. Sorry, this is not necessarily the most scripted talk, but it is just based off of my own stream of consciousness. And so next, of course, we would get things like tsunamis, volcanoes. My favorite thing to learn about was just that they find carbon isotopes from the ocean in the old growth trees, because back in the day you'd have so many bears and eagles and wolves and assorted humans always taking the things from, even in places like Montana, 1,000 miles away from the ocean, there'd still be the salmon making that way all the way upstream. And so the way that there was all sorts of migratory fish and large predators worldwide that did help create a lot of these old growth ecosystems, and they've been disrupted by the logging and the dam and the civilization and the concrete everywhere and soil erosion. That is the real crisis of history from what I can tell. Is soil erosion is the biggest non-existential threat to humanity, not just an imaginary one. That is very real. And just the way that, so remineralization would happen all the way from the oceans to 1,000 miles inland based on migratory patterns of fish and then the eating patterns of predators. So every time a bird poops on your lawn, and say it might be some sort of seabird, then that means you're probably getting some more remineralization beyond just the nitrogen of the poop. There's also the fact that there is always ongoing processes of life feeding on life, and then transporting and digesting that energy and placing it elsewhere. And so yeah, if we think of like broad scale remineralization strategies, that's where I have to really say the sea minerals, in terms of what I like to bring home as unwashed seaweed, which can have its own contaminants. They finally did a large study, sample study from Seattle to Victoria, and of course the closer you are to urban population, the greater industrial toxin and heavy metal content you're going to find in seaweed. But it is still low enough on the food chain that it's like those PCBs were found to be one of the worst contaminants on seaweed aren't going to be as bad in some areas. So it is good to, maybe if you are in the Salish Sea area, to take a look at some of this data that's come out. So that way, of course, you would just know better than to harvest seaweed from near Seattle or military base, which we have a lot of naval bases in this area. I live next to 2 oil refineries, and so it always does bother me, you know, even though I'm a couple miles away, but you go far enough on this island I live on, then you start to get closer to a naval base. So it is probably inescapable, some of the contaminants. Obviously, like microplastics is going to be a big thing, and the ocean's so full of microplastics that using seaweed as a mulch and a mineral and a microbe fuel is not necessarily, you know, 100% the cleanest, but it is what we're dealing with everywhere. It is everywhere, and it's inescapable, the industrial pollution. So that's where you work with what you got. And so yeah, what do we got? One popular thing to look for, of course, is that, the basaltic rock dust, glacial till. You can go find silt from river, and it is why the riverine valleys were so very fertile, and especially a place like Skagit County where I live. They've messed it up. They've stopped the flooding, but the flooding was what brought that mineral down, just corroded down by the glaciers and then flushed into the water, which is a form of soil erosion, but it's happening on mountain peaks where there's no root-based thing really growing. You might get some algae, and so just all that stuff that washes downstream can be super beneficial, if you're actually allowing the natural processes to happen. But otherwise, you get river mouths silting up, and then you get the river mouth silting up, so much that it's causing the oxygen to drop, and there's less of aeration happening, and then you get the hypoxic events where there's the big die-offs happening. Like every year off the Columbia River, there's generally a big die-off when enough combination of farm fertilizers and pesticides and stuff cause a big swelling of algae, but then those algae use up so much of the oxygen that then all the slightly higher life forms like crabs and stuff die of basically oxygen starvation in the water. And so that's where we've messed up so many processes, and our goal as stewards of soil is to take the advice of Wendell Berry and do unto those downstream as you would have those upstream do unto you. And so we want to mitigate runoff. We want to be actually cleaning the water as it's passing through the landscape, and this is where healthy soil acts as both a filter and a reservoir. And so that's a big part of what we all need to do for global earth repair is do lots of soil building. I guess one of my final things I'm going to start getting into is simple strategies for microbial breeding. I'm just going to more give a brief overview of that, and not so much delve into the breeding, just talk about a few different varieties, just because there is a lot of videos already made on these different processes. But I always, in my gardening and orcharding, wanted to not spend money, basically. I didn't want to have to go buy things. I wanted to be able to just source them locally. And then as I got into things like nature farming, that's where I started learning about things like bokashi. I of course I'd heard about compost tea probably back by like 2004 or 2005 as promoted by Elaine Ingham, but I never got much into the compost tea myself. But then I started learning some of the recipes coming from Japan and Korea and India and Thailand, Philippines, and folks were taking ideas about fermentation. And the natural fermentation processes are just the marriage made in agricultural heaven, because so many things act both as plant growth, plant symbiotes are also our gut symbiotes. So this in the soil, in the healthy soils, we have all sorts of populations of the algae, the amoebas, the bacteria, the actinomycetes, the streptomycetes, and then of course all the higher life forms and the crustaceans and the microarthropods that feed on those creatures. And then from there, you get all the higher life forms from there as well. But it often gets called the soil food web. Well, we also have basically a gut food web, and understandings of soil health, human health, mental health have all evolved, that we can see that there are a number of key players, that in our own gut we get tons of lactic acid bacteria and other assorted digesters in our own microbiome that also produce the neurotransmitters that are naturally needed by our nervous system. And so if you basically eat sauerkraut, you're going to then have a greater ability to have well-being, and that's probably how our ancestors felt. They didn't necessarily need to eat the fermented food so much if they were say foraging around 100,000 years ago. But then as we became more settled and we started to rely on smaller areas to feed us consistently, fermentation became part of food storage. And so just as these fermentated microbes both unlock the nutrient availability and make things more pre-digested and bioavailable to us, then in the soil, a lot of these same sort of things like lactic acid bacteria, and yeast, and then all the assorted like symbiotic fungi, they are all doing the same thing. They're working with the photosynthesizing organisms to have shelter and a place to live, and sometimes a consistent food source. But then they are in turn are, just as we get the neurotransmitters, a lot of these same microbes in the soil are producing what's called plant growth regulators, which is the plant hormones and signaling compounds. So there's kind of a lot of overlap between the way humans and plants exist. Just as our blood cell is the same structure as the chlorophyll, the only difference being iron in our blood and magnesium in their blood. And in sea creatures, they use that same structure, and it's copper blood. So we have then neurotransmitters or plant growth hormones. I mean, it's basically very much the same sort of symbiotic relationships that get established. Similarly, when, for instance, if you're on the modern diet and you have not enough diversity of food sources, that you're giving lots of, say, really simple sugars that don't need any pre-digestion, they're not long burning fuel, they're burned up really quick. That's similar to the synthetic nitrogens in terms of how the plant no longer has to make associations with nitrogen fixing microbes. And so when we lack diversity of food sources, whether in a soil food web or in our gut ecosystem, what happens then is we are going to be reliant too much on certain bacteria. And so then what happens then is these bacteria can become pathogenic, and you see that in places where they would do like conventional agriculture with no crop rotation, and then you get outbreaks of what we call pathogens. But the pathogen and the symbiote often can be the same thing if they are kept in balance. What we consider a weed or what we consider a pathogen is often actually playing its part in its ecosystem, because we do need to have a constant cycling process. But it is about the diversity of the microbial species that allows things to be kept in check. And so then this is where we have as I mentioned, there's bokashi, which is a similar to silage or sauerkraut, a quick fermentation over about 2 weeks of fermented bran, generally in Japan, where this concept partially originated. It's a rice farming culture, so they had rice bran separated from the rest of the rice. Would just be a farm byproduct. But then if you're working with the concept of the closed loop farm, then you can ferment that farm byproduct, and then what happens then is you get a great food full of like lactic acid bacteria, yeast, and in the case of the EM1 users, photosynthesizing bacteria. And you get then to use this as a like solid state fermentation that you can top dress, and then still you would want to cover with a mulch layer, because the microbes don't want to be exposed to sunlight. They do prefer like kind of dark, damp environments for at least for continuous breeding. But we got a few types of microbes. So we have, what we could call aerobic and anaerobic, which is with air or without air. But then you have the facultative microbes, which exist in the ability to exist in both aerobic and anaerobic environments. So similarly then with mycorrhizal fungi being the ones that bond with plant roots, you have what are called facultative and obligate. So facultative bacteria would be lactic acid bacteria. It's able to thrive both on the leaf of the cabbage, and then when you salt brine it, the facultative nature of it allows it to dominate and competitively exclude other microbes, but in a way that ends up being beneficial for our food production. And so then the lactic acid bacteria in sauerkraut or kimchi, that lactic acid bacteria, if you're not using a starter culture, was from the wild microbes that were able to
to switch metabolism from being in the air to being without air. So similarly, then with the mycorrhizal world, you would get you have facultative and obligate mycorrhiza. So facultative mycorrhiza means that it could be both feeding off of dead wood in a white rot phase, and then it could be bonding to the root system when necessary. So like a lot of our favorite edible mushrooms actually are mycorrhizal. So you have chanterelles and truffles and all any number of things that your common person would recognize that is able to do dual purpose. But then you would have some mycorrhiza that would be particularly obligate, and they could only grow in association with roots. So that's where then, if you get back into the anaerobes and aerobes, you would have some obligate non-facultative microbes. So some things would only be able to thrive aerobically, and some things would only be able to thrive anaerobically. But no matter what, there's always going to be some need for a food source, and that's where domination can sometimes occur if the food source is not varied enough, or the environment stays in such a way that it's stagnant. But then that's not necessarily good or bad. It just is in certain environments. But in the environments we are trying to create in terms of healthy soil, we generally want to have a very breathable soil. We want not necessarily it to get bogged down, but then seasonally there's of course going to be variations. So yeah, bokashi is a as I mentioned earlier, is a using facultative microbes to do a fermentation that then when you expose these microbes to the air a couple weeks later, they're able to thrive once again, and then help and assist in the breakdown of your mulch and organic matter systems. Or you can use up to 1,000 pounds of bokashi an acre just about. But then the idea in nature farming is that you would not be necessarily going to the feed store, but you would be creating these fermentation food sources from your own waste stream, such that there is zero waste then in your farming. Then I mentioned earlier starch bubble tea, which would be to go, in this instance, I'll go to this old Gravenstein, and maybe we'll go to the next old Gravenstein. And we can see, okay, this tree is about 100 years old, and we want to get the donor microbes. So that's the sort of soil you're looking for in the forest when you are looking for the donor microbes. You want to have a very black, just beautiful soil, and often, bits of mycelium. So you can see the white there. And what you'd do is you would take a handful of that beautiful forest soil, and you would inoculate it, or use that as your inoculum. And then you use the simple food sources that you have available. In some cases, it can be a boiled potato, or say you had rice that sat out for a few days that was too old. You could then fill up a sock with the forest soil, and you can fill up a sock with a cheap starch source, and then you would tie that to a stick and let it sit in a barrel for a few days. And in the water, the microbes from one sock, the inoculum, would be migrating over to the other sock with food source, and you'll start to see a little bubbling and circulation action happening. And when that starts to break down, it means the microbes are eating each other. And then you can dilute that about 10 to 100 times, depending on what you're working with and how wet the environment is. And then from there, just go spread this this brew of the forest microbes out around young trees, to then help give them the donation of many years experience bonding and making allies, and finding microbes that are able to mine different minerals. And then it really can give you a jump start on your ecosystem when you are doing the fermentations. I've done a lot of what's called IMO over the years. I don't do it so much anymore, but it comes from
some really old techniques of the fermentation of rice, which to make rice wine, you can't just add yeast. You need the enzyme amylase, and so the amylase enzyme is produced by a molding fungi that's known as Aspergillus oryzae, which is related to the black molds that can cause many issues. But then humans have domesticated over, starting close to at least 9,000 years ago, humans started letting things like rice and sweet potato start to ferment a little bit with the mold, and then they realized that when you then added water, or maybe it was a happy accident, but basically you do a pre-fermentation, solid state pre-fermentation on your grains, and using the Aspergillus oryzae and associated microbe consortiums, and then from there you get the whole pre-digestion, where the starches then are broken down into simpler sugars. So then yeast, which is not able to break the starches into sugars itself, is able then turn those sugars into alcohol. So now IMO, as taught by folks like Master Cho from South Korea and his acolytes, they do this whole go and capture the donor microbes using a rice basket in the forest, and it's a really beautiful thing. But then I did that enough years that then you just continue. If you feel that you've gotten the microbes there in your ecosystem, and understand that the microbe spores are also just carried on the wind everywhere, it's more about, I feel at this point, it's a build it and they will come philosophy. And so if you do the proper amount of just create the healthy environment and provide those mineral sources that are a food in themselves for the microbes will continue to build and sustain themselves. And microbes aren't necessarily something you need to apply every year, I feel, anymore. I mean, if you are dealing, say, with some real issues with like fungus that are of more what we call pathogenic variety, then that is where you can try to use microbes preventatively, and then use microbes as almost prophylactic. But no matter what, it is about ounce of prevention is worth a pound of cure. And so it is about, if we get the good carbon in the soil and we get the mineral balances well, then the microbes are naturally going to be there. And so, yeah, like I said, it is kind of a build it and they will come. But sometimes if you're working with as many places on this planet are kind of degraded, then you need to speed up the process. And there's no reason not to enlist the wiser older generations of forest lands and whatnot in the ecosystem repair. And so I feel that humans should be more like squirrels and birds, and just like our food crops just should be accidentally being propagated everywhere every time we poop, basically. And then we would not be so much in the mess we're in now. I guess I'm going to wrap this up, but yeah, so I hope you enjoyed my talk about microbes and minerals and mulch are whatever order you say it is, but making the magic and helping the soil do its thing. And that's kind of where we get into with the etymology. Even humans, like, we're all of the same root, right? We're all radically here, trying to just find our place on this planet. And if we basically can teach the younger generations, then we might have a chance. Because then if everyone started playing, say, a game called "Let's build as much soil as possible everywhere till we die," then the next generation, they're going to inherit just softer land, cleaner water, and we can all work on cleaning up the air from there. And so thank you for listening, and I'll be taking some questions